Welcome to this brief introduction about ionic bonding. As it says on the screen, this should be 2 of your 45-minute lessons for this week. There's a brief starter activity, which is allowing you to test your knowledge from third year, which you should hopefully be able to achieve, and the answers appear up on the screen for you as well. The two main learning intentions of this lesson are that you'll be able to tell me what an ionic bond is, and that you'll also know the structure of that ionic compound forms, i.e. the structure of all ionic compounds. There is a little activity sheet for ion formation from the previous lesson that you can complete now. In terms of all chemical bonding, it's important to remember that every chemical bond, regardless of what type of bond it is, exists so that compounds and molecules are able to achieve a full outer shell of electrons, which provides that stable electron arrangement. It's that same arrangement that the noble gases have. 3 noble gases are given down at the bottom of the screen, and you'll be able to see that each of them have a complete outer shell. So our helium atom has 2 because it only has 1 shell. Our neon has 8 on the outer shell, and our argon has 8 on the outer shell as well. It's important to consider that in terms of bonding, only the outer electrons are involved in chemical bonding. So regardless of what's inside, it doesn't matter. It doesn't matter how many shells there are. It is only the outer shell that makes any difference to chemical bonding. In terms of chemical bonding, there are 3 types of bonding that we will look at in National 5 Chemistry. One is covalent bonding, one is ionic bonding, and the other is metallic bonding. Ionic bonding is the focus of today's lesson. There's a brief video on YouTube that you'll be able to look at and answer the 3 questions that are on the screen. Ionic bonding. The definition of ionic bonding is that it is the electrostatic attraction between oppositely charged ions. This means that it is the attraction between both positive and negative ions that are formed within a compound. They are formed between metals and non-metals. Metal atoms, because they're on the left-hand side of the periodic table, remember, will lose electrons to achieve a stable electron arrangement to get that full outer shell, whereas non-metals on the other side of the periodic table, on the right-hand side, are going to gain those electrons that are negatively charged and become negatively charged ions. When reacted together, the metal atom transfers electrons to the non-metal atom. So the metal is going to give away its electrons, achieve a stable electron arrangement, and the non-metal is going to collect those electrons in and form a stable electron arrangement of its own by completing the shells. This means that the metal has formed a positive ion and the non-metal has formed a negative ion. And it's the attraction between these 2 ions that have formed that strong ionic bond. So a little summary. In an ionic compound, there's a transfer of electrons, and you can see from the graphic on the screen that the sodium atom is giving away its electron to form a positive ion, while the fluorine atom is accepting that electron to form a fluoride ion. So here's an example of sodium chloride. So we start with our sodium atom and spot here that sodium has that 1 extra electron at the outside, and a chlorine which has a gap to fill on its outside shell as well. So that 1 electron will move from sodium and to chlorine and will form our ionic compound. So notice here we have 1 less shell on our sodium ion, and over here on our chloride ion we have all the same number of shells, but we have that extra electron has moved, that red dot to signify it was from the sodium, has moved over to the chlorine to form sodium chloride. Notice too that our sodium has a positive charge while our chloride has a negative charge. You could have a go at drawing this out for lithium fluoride. They'll be in the same groups, and hopefully you'll be able to see a similar sort of thing happen. And the answer, what you should expect to find, is shown on the screen now. Our next example is of magnesium and oxygen. So here's our magnesium atom and our oxygen atom. Again, notice that magnesium has extra electrons on the outside, so it's got one here and one here to show that there's two extra electrons. And in our oxygen atom, we have got two gaps. We've got one down here at the bottom and one over here at the left. So to form our two ions, we'll have two electrons will move across from our magnesium to our oxygen, and you can see these on the right hand side, our two red dots signifying they're from the magnesium, and our oxygen ion, our oxide, now has a 2- charge, while our magnesium ion has a 2 positive charge. Remember, throughout this process, it is only the outer electrons that are moving. There's no movement of protons or neutrons. They are still safely there in the nucleus. You can have a go at beryllium sulfide and try to draw a similar reaction scheme. And there's the answers that you should end up with if you were to do that. So beryllium 2+ and a sulfur 2- ion. In terms of ionic compounds, when they form structures, so here's an example showing what's happening with an ionic bond. In every ionic substance we will have positive ions next to negative ions, and between each of them there is a strong electrostatic force. Every positive ion is not just connected to one other negative ion, it is connected to every ion that is around about it. This means that our ionic compounds form into what we call lattices. Basically large cubes where they are packed closely together and have several of the ions around them. So every positive ion, we can see our sodium positive is signified by the little pink ones in here, and if we were to pick one in the middle, it would have one above, one below, one to the front, one to the back, and then it would have one to the left and one to the right as well. So every sodium ion would be attracted to 6 other chlorine ions, and this is what forms a very strong attraction between the positive and negative ions, and is the basis of our strong ionic bonds. So the structure for ionic compounds is known as an ionic lattice. This activity allows you to try and consider the ratio of metal to non-metal that will be involved in an ionic compound. Because different metals and non-metals will lose or gain different amounts of electrons, you might need to have some additional ones there. Most of the examples we've considered has had 1 electron moving to fill 1 gap, or 2 electrons moving to fill 2 gaps. But what happens if you have magnesium and chlorine, for example, where magnesium will lose 2 electrons, but every chlorine will only be able to accept 1. So have a wee think about that as you go through this activity. And there's an ionic bonding worksheet for you to complete that is just like the ion formation worksheet at the beginning of the lesson. So as I said, ionic compound is formed from millions of ions packed together in a regular arrangement that is the ionic lattice. Here makes it nice and obvious that you've got lots and lots and lots of them packed very closely together, and they can form in different ratios. So our example down here is that we've got sodium oxide. As you can see here, that sodium will lose 1 electron, whereas oxygen can gain 2, and so you end up having 2 sodiums bonds to every 1 oxygen in a 2-to-1 ratio. Our magnesium and chlorine goes the other way, with magnesium losing 2 electrons and chlorine gaining 1. So that means for every magnesium you will have 2 additional chlorines. And here's just an example of a very big model showing what a grain of salt might look like, for example, if you were to blow it up and look at each of the little atoms that are close together. thank you for listening. There is a quiz for you to complete as usual, and please make use of the Unit 1 self-check booklet. It has a series of past paper questions for you to try with answers at the back for you to make sure that you're understanding what you are thinking about. As always, if you have any questions, please feel free to get in touch.